Video for Chem 161, where we'll be discussing some Chapter 1 content called Dimensional Analysis, which is an approach where we inspect the information provided into a mathematical or chemistry type question, and we take our approach and guide our approach to answering a question based on conversion of units from one set to another. Okay, so that's really what dimensional analysis means. So here's a table of unit conversions that's available to you on your course website. It's also would be provided to you in in-person and in-person quizzes and tests. And you should consider using this here for your homework and your online quizzes. And so let's take a look at the information available. You can see it's grouped by the sort of information type, length, mass, temperature, etc. We can see here that some of the common informations that you might be familiar with, like how many feet are in a mile, are reported. And so in this regard, perhaps you already know that there are 5280 feet per mile, and that's something we can use to transform information from miles into feet, for example. Others that you might know are perhaps the centimeters to inch identity shown here, where there's 1 inch for 2.54 centimeters exactly. And we can use these identities to make what are called conversion factors that we'll use in the problems on the following slide. And so what we'll do here is let's take a look at the first one, knowing that 1 mile is equal to 5280 feet. And let's simply do a mathematical exercise and divide both sides by one of these bits of information. So let's start by dividing both sides by 1 mile. You can see here that the left-hand side reduces down to the number 1, and the left-hand side becomes what we call a conversion factor. So a conversion factor is really an exercise where we are multiplying by 1. And so as you know from maybe other courses, we can multiply any quantity by 1. This is just a very complicated looking number 1, and it has unit information that distinguishes it from the left-hand side. Conversely, another conversion factor that can be had by not dividing both sides by 1 mile, but instead dividing both sides by 5280 feet, gives us the inverse of this result, where again 1 mile is going to be equal to 1 mile per 5280 feet is equal to 1. All right, so in this regard, we've been able to access 2 conversion factors from one identity. Let's talk a little bit about Sig Figs quickly in these. So you'll see that in the header we have an instruction here that tells us about this. We have the idea that whole numbers below and those that have the word exact beside them refer to values that are infinite in sig fig quantity. So in our example here for 2.54 centimeters exactly to the 1 inch, we see that the 1 inch piece has infinite sig figs because that's a whole number, an integer there. And we have the 2.54 listed as being exact. So that 254 does not have 3 sig figs, but has infinite sig figs because of that exact parenthetical statement made there. Down below in the 1 mile equals 5280 feet, you can see that we do not have the exact listed there. So the information at right has 3 sig figs there and infinite sig figs on the 1 mile. Okay, so that's how we use the information. And so just as a reminder, how we kind of look at that is listed over here for us. Okay, so let's take a look at some examples where we do some dimensional analysis and use these conversion factors to help us. Okay, so the first question might be, as an example, we might be charged with the exercise of converting 840 inches to decimeters. Okay. So if we were charged with doing this, the dimensional analysis approach can be framed by the idea of simply putting what we're after. So we're after some new number here in decimeters. And we're going to start with the information on the right-hand side here that is given. So that's the 840 inches. And now we can start to think about what's our map to the answer. So maybe we'll list that here as an approach kind of set of notes. So our approach or our map to getting to the answer, we clearly have to start with the inches idea and transform this into something else. So on the previous slide, we saw that 1 inch was equal to 2.54 centimeters. So it looks like we could transform the 840 inches into centimeters quite easily. That is a step in the right direction in my view, because then we're getting closer to something that we may have learned about from earlier work on the definition of the decimeter, meaning that there are 10 decimeters per meter. So once we're in centimeters, we're just 2 steps away from being able to use that last bit of information. So how does this translate? We want to go from inches to centimeters using that identity we just saw. If I can go centimeters into meters, I'm now prepared to transform that all the way into decimeters, knowing that there are 10 decimeters per meter. Okay, so that's our approach. So I typically use dimensional analysis with the format of using parentheses because it handles exponent information a little bit more cleanly, as you'll see. But there's another approach where we can use kind of a railroad type structure to show the same bit of information. So we'll show you both here and you can choose which one you like. So the first idea was to try to transform the inches into centimeters. So we want to cancel inches. So I'm going to position the inch information in the denominator of my conversion factor. If you recall on the previous slide, we saw that 1 inch is equal to 2.54 centimeters exactly. Okay, so that means that there are 2.54 centimeters per inch, which is equal to 1, which is the conversion factor that we're going to use right here. Okay, so 2.54 centimeters per single inch. Okay, doing that, you can see here that in the dimensional analysis approach, we've now canceled the inches and we inherit the units of centimeters at that point. So again, only one of the sort of 3 major steps we need to take. We know that there's going to have to be another conversion factor to transform this information further. So we want to eliminate the centimeters this time, so we'll put that down below. We want to try to get into meters, so we'll put that as the numerator. And we know that there are 100 centimeters per meter. And this allows unit cancellation to now transform our centimeters away, and we will be in the meters at this point. Okay, and the final idea, so we've kind of taken this step, is now to go to decimeters. And so we recall from working with prefixes that the 1 meter needs to be eliminated, and we know that equals to 10 decimeters. And this is now going to show the final unit cancel meters, and we will inherit the decimeters as intended. Okay, so after kind of doing this, what you would do on your calculator is simply work with 840 times 2.54 divided by 1 times 1 divided by 100 times 10 divided by 1, and we end up with 213.36 decimeters reported on our calculator. Now let's take a look at Sig Figs to help us there, and we can be confident that we need to use Sig Figs because we've done multiplication and division in transforming 840 into 213.36. Only multiplication division, so we respect Sig Fig type guidance there. We knew that these were identities that had infinite number of Sig Figs because they're provided by the definitions for those prefixes. And we saw in the previous slide that the 2.54 was an exact amount equated to the 1 inch. So there's infinite Sig Figs in this first conversion factor as well. Multiplication division, we report our final answer to the fewest number of Sig Figs that we have in our work. And so the fewest this case is whatever's in the 840. And so this is a 1-2 Sig Fig number where the final 0 is not significant since there is no decimal point. And so we know that we need to report 2 Sig Figs on the 213 value. And so we're going to work with those first 2 digits showing significance and report this out as 210 decimeters, since we need the 0 to make sure that the quantity of 210 is there, not simply 21. Okay, so there's our final answer for that problem there. I mentioned the railroad approach, so that's going to look something similar, where we would start with the 840 inches, and we put that at the beginning kind of quadrant, if you want, of our little railroad. And these conversion factors are going to be in the boxes that follow. Okay, so the sort of boundary here is the divide sign in my conversion factors above. And so in this case, the 254 centimeters and the 1 inch goes here. In the next conversion factor, we have the 1 meter and the 100 centimeters here. And then in the final conversion factor, we have 10 decimeters to the 1 meter here. And this is our final answer, and that gives us the same outcome, obviously. And you can see that the unit canceling is positioned nicely. Inches cancel inches, centimeters cancel centimeters, meters cancel meters, and we end up with the decimeters as intended. Okay, so that's the sort of railroad approach, if you like that visual. Okay, let's take a look at another example here where we are asked to convert .00 liters into cubic inches instead. Okay, so if you want to pause the video at this moment, you can, to try to set this one up, and resume the video once you've had a chance to do the work. Okay, so we started before thinking about our approach, so we'll just do that one more time here, our approach. I think what we'll do here is, of course, begin with the liters, and I think what we want to do is ultimately work with this same bit of information above to show a new tool for us. So this is a one-dimensional bit of information. The length is the one dimension that I'm referring to there, and we can use that to help us on two-dimension and even three-dimensional information like we have here in volume. So volume, of course, can be reported in liters or milliliters, but also the X by the Y by the Z full volume product there. So that is length by length by length is, of course, volume. So recalling that there's 1 cubic centimeter per every milliliter, I think it's going to be advantageous to first get into milliliters, then get into cubic centimeters, and then we should be able to use that information above for the 1 inch equal 254 to ultimately get into inches cubed, and we'll show that in a second. Okay, dimensional analysis on the left-hand side, we want some number, and we're after inches cubed, and we're going to start with the 1.00 liters. We'll use the parenthetical approach here rather than the railroad, but you can do the same there. And so our first idea was to go from liters into milliliters. So let's cancel 1 liter with 1,000 milliliters. We do that first step. The next step was to get into centimeters cubed. And so to do that, we've got to cancel the milliliters that we just inherited and get into the centimeters cubed. So by definition, 1 centimeter cubed is 1 milliliter. So that's looking good. And now we have our new conversion factor to work with here. So here, well, we know that we could cancel one of these centimeter cubed kind of units with going into inches if I use that above information. So we knew that there was 2.54 centimeters for every inch. But this only does work on one of the 3 that we need to do. So the trick here is going to be to cube this conversion factor. When I put a 3 at that position, that cubing is doing work not only on the units, but don't forget, also on the coefficient out here. And it's doing that on both numerator and the denominator. So this final conversion factor with a cube out front, simplified, would be 1 inch cubed is going to be some number of centimeters cubed. And to get that number, we have to take 2.54 and cube it, which is of course the same as 2.54 times 2.54. Okay? And so our denominator here after simplification becomes 16.387064. Okay? So that final conversion factor in red is the same as the one in blue, having taken the cubic information into the rest of the conversion factor. Okay, so that's our trick there for working with a one-dimensional bit of information up here and converting it into a 3D information in the volume information that we need here for this question. Okay, so on our calculator, what we're going to do is simply do 1.00 times 1,000 divided by 1 times 1 divided by 1 times 1 divided by the 16.387064, and we get an answer here that is 61.0237441 inches cubed. Okay, we can check our work. So many of you probably have a 1 liter bottle, about a quart of water that you're used to familiar working with. And so 1 liter of water, you can imagine that being roughly the size of, maybe 2 softballs or something. So is the volume of that, does that make sense? Is it about 60 cubic inches? So this is how we kind of check our work. So thinking about what that would look like as a cube, you could take the 61 and take the cube root of it. And so we're talking about 4 inches. So thinking about a shape held between your hands, 4 inches by 4 inches by 4 inches. Does that space, if you're kind of positioning your hand in figures to make 4 inches by 4 inches and 4 inches of space, does that look to be about the size of 1 liter or, a very large softball or 2? I think so. So this number makes sense. That's how we check our work. Okay, and now let's do Sig Figs. Well, we've done infinite Sig Figs on many of these conversion factors, so that again is infinite Sig Figs. This here is infinite Sig Figs. We worked with a 254, and those were infinite Sig Figs. So everything in our final conversion factor is also infinite Sig Figs. So we're going to report out to the fewest that we had, given that we did multiplication and division. Let's look at our number. We have 1.00. The trailing zeros after the decimal are significant, so this is a 3 sig fig number, and we need to report out with a final value that's 3 sig figs. So we'll do that here, and we'll give our final answer here as 61.0 inches cubed as our final answer. Okay, that's dimensional analysis. One was more straightforward and simply going in a one-dimensional transformation of inches to decimeters. A third one, the trick there was to work with the cube information carefully on a linear length type identity that we had from our conversion table on the previous slide. And in doing so, we were able to handle a volume type question.